Hypothesis testing. Population mean when the variance is known or unknown and n is less than 30. So, for this lesson, ang kukunin naman natin if kapag yung n natin is less than 30. So, assuming a population follows a normal distribution, the appropriate test statistic for testing a claim about a population mean when the population variance is assumed to be known or unknown and n is less than 30 is the t-test for the single mean. So, last video, ang ginamit natin doon ay z-test dahil ang n natin is greater than or equal sa 30. But here, if n is less than 30, ang gagamitin nating test statistic is the t-test. So, ang gagamitin naman nating table dito ay ang table natin or the t-distribution table. So, the formula that we are going to use is the t-test, which is pareha lang din naman siya sa ating z-test, pero the symbol of our standard deviation is s, since our n is less than 30. So, again, we have the sample mean, the population mean, the standard deviation which is s, and the sample size which is our n. So now let's move to our example. Example number 1. It was announced over the radio that the average price of the kilogram of pork liempo in Metro Manila is 195 peso. However, a sample of 15 prices randomly collected from different markets in Metro Manila showed an average of 200 peso and a standard deviation of 9.5 peso. Using a 0.05 level of significance, is there sufficient evidence to conclude that the average price of pork liempo in Metro Manila is more than 195 peso? So, normality is assumed over the population. So, first, let's write our given that we have in the problem. So, the sample mean is equal to 200 peso. And the mean is 195 peso. The standard deviation is 9.5, n is 15, and the alpha is 0.05. So, to know if our alpha is one-tailed or two-tailed, we need to get the null and alternative hypothesis. So, the null hypothesis is mean is equal to 195, and the alternative hypothesis is mean is equal to 195. So, nakuha natin yung greater than dahil it says in the problem that more than 195. So, since ang ating alternative hypothesis is greater than, so, ang ating alpha is one-tailed. So, since it is greater than, nasa right yung ating rejection region. So, next natin is to identify what test statistic we are going to use. Since our n is 15, we will use the t-test or the t-distribution table. So now, let's move on to our finding the critical value using the t-table. So, dito, hindi na natin kailangan pa mag-divide 2 to get the one-tail. Dahil sa ating t-table, ang titignan natin is yung mismong level of significance and the degree of freedom. Kung natatandaan nyo, to get the degree of freedom, we will subtract n minus 1. So this is our t-table, t-distribution table. So kung nakikita natin sa table natin, meron na tayong level of significance. So meron tayong one-sided of alpha and two-sided of alpha, which is the two-tailed. Since one-tailed yung ating alpha, so dito tayo titingin sa ating one-sided alpha or one-tail natin. So here, the alpha is 0.05. So, ito yung ating 0.05. So, dito sa ating part na to. Ayan. Next natin is to find what is the degree of freedom. So, the degree of freedom is equal to n minus 1 and our n is 15. So, yung n natin ay 15. Therefore, 15 minus 1 is equal to 14. So, yung degree of freedom natin ay 14. So, this is the 14 and then nag-intersect siya sa ating 1.76. So, therefore, the critical value is 1.76. Since greater than siya, it is positive. Nasa right side of the normal curve tayo and that is positive. So, kaya ang critical value natin ay positive 1.76. So, nandito yung ating critical value nasa positive part which is 1.76. So, this is the rejection region. So, dapat hindi magfo-fall dito yung ating test value. So, pag nandito yung test value natin, then we will reject the null hypothesis. Pero kung wala naman dito sa part ng rejection region yung ating test value, then we will accept the null hypothesis. So, let's move on in computing the test value. So, like what I said, if n is less than 30, we will use the t-test, which is similar lang din naman siya sa ating z, pero ang symbol ng ating standard deviation ay s. So, t is equal to the sample mean minus mean over standard deviation divided by square root of n. So, we will write the given here. So, ang ating given ay yung sample mean is 200 minus natin sa ating mean which is 195 divided by natin sa 9.5 na standard deviation and divided by the square root of 15 which is yung n. Then, simplify natin. 200 minus 95 is equal to 5 and the square root of 15 is 3.87. So, again, if ang ating sagot ay more than 2 decimal, we need to round off up to 2 decimal places para mas madali din nating makompute. Since the answer is hindi naman siya nagkakalayo. So, next is to simplify 9.5 divided by 3.87. It is equal to 2.45. Then, 5 divided by 2.45 is equal to 2.04. So, the test value is 2.04. So, this is the normal curve and our critical value is positive 1.76. So, yung test value natin ay 2.04. So, of course, nandito yung ating 2.04. So, let's say this is 2.04. Then, nasa rejection region siya. If nasa rejection region siya, then we decide to reject the null hypothesis. Since the computed test statistic t is equal to 2.04 falls within the rejection region, which is 1.76, we will reject the null hypothesis. Then to conclude, there is a significant difference between the sample mean and population mean. Thus, the average price of pork liempo in Metro Manila is more than 195 peso. So may difference yung ating sample mean na 200 doon sa ating population mean. So, hindi natin pwedeng gamitin yung sample mean kasi hindi natin makukuha yung exact ng kinukuha nating average sa ating population mean. So, therefore, we reject the null hypothesis. So, next example natin is example number 2. The average amount of rainfall during the summer months is 11.52 inches. A researcher in Pag-asa select a random sample of 10 provinces and find the average amount of rainfall last year was 7.42 inches with a standard deviation of 1.3 inches. At 0.01 level of significance, can it be concluded that the mean rainfall last year was below 11.52 inches? So now let's write the given that we have in the problem. The sample mean is 7.42. The mean is 11.52. The standard deviation is 1.3. N is 10. And the alpha is 0.01. So, kung makikita natin, yung alpha natin ay iba na. So, hindi na siya 0.05. So, ngayon, meron tayong 1% level of significance. So, ngayon, hahanapin natin kung this is for one-tailed or two-tailed. So, we need to find the null and alternative hypothesis. So, the null hypothesis is equal to 11.52. And the alternative hypothesis is less than 11.52. Paano ba natin na-identify if this is less than? So, if you can see here in our problem, so can it be concluded that the mean rainfall last year was below? So, kino-conclude ba natin kung below ba siya? So, therefore, it is less than 11.52. And since this is less than, this is, so yung alpha natin ay for one-tailed. Then, after that is we need to identify which test statistic we are going to use. So, since n is less than 30, dahil 10 lang yung n natin, then we will use the t-test. And we will use also the t-distribution table. So, now we are going to find the critical value using the t-table. So, this is the t-table. And the alpha is 0.01. So, since this is one-sided or one-tail, so one-tail tayo titingin. So, this is the one-tail. And then, yung 0.01 natin ay ito po. So, therefore, nandito yung ating critical value. And then, the degree of freedom is n minus 1 is equal to 10 minus 1. So, yung n natin ay 10. And then, yung degree of freedom natin ay 9. So, ang ating critical value ay kung saan siya mag-i-intersect. So, ang critical value natin ay 2.82. So, since ang ating alternative hypothesis ay less than, so nasa negative part siya ng ating normal curve, then the critical value is negative. So, that's why critical value is negative 2.82. So, nandito siya sa ating normal curve. And let's say this is the negative 2.82. And then, this is the rejection region. So now, we will compute the test value using the t-test, which is t is equal to the sample mean minus mean divided by standard deviation and divided by the square root of n. So, the sample mean is 7.42 minus mean is 11.52 and the standard deviation is 1.3 divided by the square root of 10, which is yung n natin. Then, let's simplify. 7.42 minus 11.52 is equal to negative 4.1 and then square root of 10 is equal to 3.16. Then, we will simplify 1.3 divided by 3.16. Then, it is equal to 0.41. Then, negative 4.1 divided by 0.41 is equal to negative 10. So, our test value is negative 10. So, negative 10, so, nandito yung so, this is negative 2.82. So, let's say nandito, so, rejection region pa din yan. So, let's say nandito yung negative 10 natin. So, therefore, the decision is reject. So, we will reject the null hypothesis. So, since the computed test statistic is equal to negative 10, which is, it fall within the rejection region. So, therefore, we reject the null hypothesis. So the conclusion is there is a significant difference between the sample mean and the population mean. Thus, the average amount of rainfall is less than 11.52. So now let's move on to the last example. Example number 3. The mean content of the 25 bottles of brand S mango juice is 355 ml with a standard deviation of 9 ml. In this line, with the manufacturer's claim that the bottle contains on the average of 360 ml. So use the 0.01 level of significance. So dito, we need to write the given that we have. So the sample mean is 355. The mean is 360. And the standard deviation is 9. Yung N natin is 25. And then the alpha or the level of significance is 0.01. So we need to identify if our alpha is a one-tailed or two-tailed. So we need to get the null and alternative hypothesis. So the null hypothesis is equal to 360 and the alternative hypothesis is mean is not equal to 360. Since our the alternative hypothesis is not equal, so we can't identify if nasa positive siya or nasa negative side of the normal curve. So therefore, the alpha is two-tailed. Next is to identify which test statistic we are going to use. So if n is less than 30, then t-test is the best test statistic to use. So n is 25, so t-test ang gagamitin natin. So next natin is to find the critical value using the t-table. So the t-table, so yung ating alpha is 0.01 which is two-tailed. So yung two-tailed natin ay eto po. So yung two-sided alpha. And then 0.01 eto po. So kung makikita nyo yung difference ng one side or one-tailed and two-tailed, magkaiba po siya. So that's why we need to identify if the alpha is one-tailed or two-tailed. So eto po yung one-tailed natin. So ibang column po siya. Kaya kung dito po tayo titingin, mali na po yung makukuha nating critical value. So dapat po tama yung titignan nating critical value. Dahil kahit konting decimal lang ang difference nila, what if yung ating test value na nakuha ay konti lang din yung difference dun sa ating critical value. So, mag-iiba yung ating decision. So, ang ating two-tailed alpha natin is 0.01. So, dito tayo titingin. Then, next is to find the degree of freedom. So, nandito yung ating critical value. So, next is to find the degree of freedom. So, the degree of freedom is n minus 1, which is 25 minus 1 is equal to 24. So, we need to find the degree of freedom in our table. So, eto yung ating degree of freedom. So, kung makikita natin wala yung 24, so we need to go further. So, eto yung ating next or yung karugtong ng ating table. So, yung 24 natin ay eto po. So, eto yung degree of freedom. So, kung saan po siya mag-i-intersect, yun yung ating critical value. So, dito siya nag-intersect. So, the critical value is 2.80. Since this is two-tailed, then the critical value is positive or negative 2.80. Again, pag not equal, so two-tailed siya, and then hindi pa natin ma-identify kung nasa negative part siya or positive part yung test value natin. That's why, yung critical value natin is positive and negative 2.80. Since we have the critical value, so let's say nandito yung ating critical value sa ating normal curve. So let's say this is negative 2.80. And then, this is the positive 2.80. So this is the rejection region. So ito yung rejection region natin. So pag nag-fall dito yung ating test value, then we will reject the null hypothesis. And then pag hindi naman, so we will accept it. So now we have the critical value. Now let's find the test value. So to find the test value, we will use the t-test. So t is equal to the sample mean minus mean divided by the standard deviation divided by the square root of n. So we have the given here. So 355 minus 360 divided by 9 divided by square root of 25. Then let's simplify. Negative 5. So 355 minus 360 is negative 5. And then square root of 25 is 5. Then 9 divided by 5 is equal to 1.8. Then negative 5 divided by 1.8 is equal to negative 2.78. So let's put the test value to our normal curve. So if you can see, 2.78 yung ating test value. And the critical value is 2.8. Kung makikita nyo, ang difference nila is 0.02. So that's why we need to be careful in finding the critical value in the table that we are using. So the test value is negative 2.78. So nandito yung negative natin. So negative 2.78 since 2 lang, 0.02 lang naman yung difference niya. So magkalapit lang siya. So this is 2.78. And since wala siya sa ating rejection region, we will accept the null hypothesis. So since the computed test statistic is negative 2.78, which is do not fall within the rejection region, therefore we accept the null hypothesis. And the conclusion is there is no significant difference. So walang pagkakaiba yung ating sample mean and the population mean. So pwede natin gamitin yung sample mean natin or yung sample, or pwede tayong kumuha ng selected provinces to get the mean dahil wala naman siyang pagkakaiba sa ating population mean. Kapag ka nag-survey or nag-conduct tayo ng survey, kahit ba 1,000 provinces yan. So thus, the average amount of rainfall is equal to 11.52. To summary this lesson and the previous lesson, so kahit ang given natin is known ang variance or hindi, basta kapag greater than ang ating n, greater than sa 30, ang gagamitin natin is z-test and the z-value or the areas under the normal curve. But if n is less than 30, ang gagamitin natin ay t-test and the t-distribution table.